Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Carl Carlson.
Hey, Carl. Good to talk to you again. I understand you got a couple of questions.
Yeah, I had some really interesting questions over the last week on FMEA, and I thought they'd be fun to talk about. Both of them are some of the topics that are controversial, and those are the most fun. So one of them has to do with, and we can focus today's podcast on this one, has to do with FMEA detection. And I get at least one question a month from people around the world that relate to FMEA detection, because it's probably the most challenging and sometimes the most confusing concept.
Well, the part that always trips me up is where are we detecting it? And I even had one participant in a session say, well, if we know about it, did we just detect it? I don't think so. The other thing that trips people up is the scale's reversed, at least in my simple way of thinking.
Yes, they are reversed. What's just going back maybe 30 years. I go back in decades, not years. So going back about 30 years, Ford did not want to use detection, and in the automotive, so you have Chrysler and GM were using detection. Ford didn't want to, but the standard kept using detection, so they went along with it. And then the Department of Defense doesn't use detection during product development in Mill Standard 1629, which is the one that's technically canceled but still being used. So the concept is, do we need a detection risk factor in an FMEA? I think the answer is yes. There's a lot of people that say no. And when they say no, I say, well, okay, there's still risk about detection. If you don't include it in some way, you still need to detect problems, both during product development, so they don't get in the hands of the customer. And then you also have to detect emerging issues during operation, so they don't become a catastrophic problem. And so that's the conversation. But it often starts with, do we need it or not? And then if you say, okay, we do need it, then it comes down to, are we talking product development or are we talking in operation? Because that often gets missed by people.
Yep. And it gets muddled because, we're beating on design teams over and over again, design for manufacturing, design for process, design for assembly. And so it's part of what they have to think through in the design. And so it's slicing out which detection are we dealing with here, at what level, and what nuance are we going after?
Yeah, and I've been in conversations with people, and I'm talking very knowledgeable people that on FMEA committees that toggle back and forth between the two types in the same conversation, not realizing they're going from detection during product development to detection in service in the same conversation.
And I've run into that, and I think it runs afoul of when you start scoring it, but the same concept applies. If I'm designing something and I'm trying to detect an oil pan leak, for example, or is this seal and design going to work? That's a design problem. And getting the fittings right and the torque right and all that other stuff is part of the design, in my opinion. The oil light is a detection method in the car during operation. And if either one of them, we don't know that there's a problem, we lose an engine. So it
can be very catastrophic. You're right.
So I've mixed them rather than try to, parse it out and go, well, that is in and that is not in. I tend to always go with, let's add it in. If it causes a problem, we'll fix it later.
Yeah. So the interesting part of this, and we'll take the oil leak example. If you're developing, and of course I had the automotive portion of my career, so I'll just lean on that. If you're developing a new engine in a vehicle, you want to test the engine during the product development and find out if this is a leaky engine,
right,
or not, before that engine goes into the vehicle or wherever, could be into an aircraft, before you launch that program. And so there's this whole subject, as you know, because you're steeped in this, there's this whole subject of testing and analysis as you're developing products, and how good your tests or analyses are to detect a particular failure mode and or cause. That's the detection risk during product development.
Yep.
And then separate from that, you might have a sensor, which could get you to an oil light. There could be obviously a temperature gauge, which would then flag if things start to get more catastrophic. And then you get, in many systems, you can get a response, an automatic response or a human response, an operator response.
Mm-hmm.
And that if the response is automatic, maybe it, and this one is, the example doesn't lend itself that well to that, but you could imagine some type of system that mitigates the problem so that it doesn't become catastrophic during service. That is what we call monitoring and system response. And the FMEA enables that. And that's during operation. That type of detection is a different concept. It's the same word. And like you say, there's a similarity to it. Do you detect the problem? But the test you're doing during product development isn't the same method that you would use in service. In other words, in service, it's going to be a different concept.
Well, I've seen that where it was a medical device, and it was one of these things that during the development, they were trying to figure out, could we tell if this particular issue is going to happen or not, and if it did, then we have to change the design, or we got to do something about it. But in that initial FMEA, they also put in if we're unable to fully resolve it by design, how would we make it an alert on the system so that the technicians using the system would know that it's not working? And so they kind of had a cascaded set of detection that crossed those boundaries. And it ended up that, as you know, with product design, is they kind of boxed themselves into a corner and they got a partial solution for it. But by that point, they really couldn't back out that failure mechanism. But they'd already started thinking through, well, we got to detect this in our testing. And it was a particular combination of factors that they had to sense. And so the work to determine if the problem existed during development for testing ended up getting built into the equipment.
Very good crossover story.
Yeah. Now, I've also had, it was what did they call it? It's where an IC is being attached to a circuit board, but it's not soldered, and it goes into a socket, essentially. And it was something like a 1,200 pin, great big, huge integrated circuit, some ICE, monster thing. And it had these pins that had springs that would connect to the pads underneath the chip and then connect to the circuit board. And it was all based on it being like depressing these buttons, basically. And they were getting intermittent. The way those things would fail is to be open. There would be no current there whatsoever, or voltage across it, or no current. And then, or it would be a short, and it would short with something else that it's not supposed to talk to. And then that would be a problem. And the insidious ones were in intermittents. And it's like, well, how do we detect an intermittent?
Oh my God.
And which pin?
Yeah.
And there's 1,200 of them. And so we ended up with the FMEA pretty much getting derailed at that point and said, all right, we got to go figure out how to measure this. just at all. And so we made a custom setup and had a dummy chip on it that had all this extra circuitry on it, just so we could pulse each one of the pins and record whether it connected or not, and monitor that in real time. It took them about 2 months to figure out how to do that and set it all up. And then once we knew how to detect one of those three problems, then the design work went into the socket itself to get all the pressures right and all the systems right. But there's no way to design that socket if you can't measure it.
Yeah, for sure. And then it's an interesting case study of FMEA application. And I've had this happen many times where the answer is not in the room. That's what I call it.
Yep.
Quote, answer is not in the room, unquote. And I use the recommendations column of the FMEA just to record what you described. We're going to go off and measure this or develop a way to measure it. Well,
and until you have a way that you can trust, that you understand is going to actually detect what you're trying to detect, your detection score gets really high. Because right now you don't know how to measure that. It could fail that way, and it would be bad if it fails that way, but we don't know how to detect it until it blows up. That would be bad.
Right. And let me go on a side excursion with you, just for fun here. I started out many years ago thinking the scale of severity occurrence detection is 1 to 10. I'm now very firmly in the camp of 1 to 5. And I wondered if you had a point of view on that.
I've always stayed flexible on it. It's who I'm working with, we're comfortable with. And 9 times out of 10, if they want to use a 1 to 10 scale, it becomes 1 and 2 is basically the same. 3, 4 is basically the same. And what I do is I let it go. They use even numbers or odd numbers. And then if they get a whole pile of 8s, I was like, right, well, are some of these 8s more of an 8 or less of an 8 than the other ones? Let's make some of them 7s and get some separation here.
You understand the principles, and that's so you're working with whatever it is. And the principle you're describing is prioritization.
Yeah, and if you're just blindly following a standard or a guideline or something like that, you're probably not doing a good FMEA.
I agree.
You've taught me that.
Yeah. So what I read in my book is that use as few levels on your scale as are needed to differentiate the risk, and that more often than not now that gets me to around 5. But you're right. If a company's like entrenched, their customer says it's going to be 1 to 10, fine. Let's not argue the point, because you can, like you say, you can end up with 2, 4, 6, 8, 10 as a way to address that. Or I just don't want to see people get bogged down. Is it a 1 or a 2 when the meaning doesn't add value?
That's right. Yeah. Who cares? Make it 3 and it still won't rise to the top where we're going to do anything about it. So.
Right.
Yeah.
But circling back to the clarity thing around detection, you're right on your first comment, which is higher detection number means higher risk, but it's a lower likelihood of detection. And that's what gets one of the things that gets confusing to people. A low likelihood of detection, they think, well, that should be like a 1. No, that's high risk.
Yeah.
We'll give that a 5 or something. So that was one of the areas that it gets confusing. And the other one is this: when are you detecting? And even in product development, if you detect it early, that's better than detecting it right on the assembly line before you ship the product.
Oh yeah. I always looked at it as you want to detect it well before a whole bunch of other value add comes into it. Because if I've completely built up the system and now I found that the crankshaft doesn't work, I got to disassemble the whole bloody thing to fix that one part, or scrap it, the whole thing, depending on the assembly. I've spent plenty of time working on production to move and it's gotten to be frustrating, as most people say, well, we only know how to measure paste and we know how to measure temperature here and we know how to measure everything else goes end of line. And that is a waste of time. Come on, let's move this detection further up. And we go, what do they call it? Dock the shop to stock. We don't do incoming. We don't do anything else, right? Well, you're reworking 3/4 of the components that you fail to inspect, and you're not working with your vendor to do it right and everything else. And they were hidebound, or whatever the right word is. They were, no, we can't afford to do measurement earlier in the system. It's just too expensive, makes it too complicated. He says, you're scrapping, all of this stuff and doing all this rework, which deteriorates its ability to do what it's supposed to do, blah, blah, blah. And they just head in the sand, would not do it.
I'm working on this committee that's replacing Mill Standard 1629. It's called SA 1025 is the committee. It's got really good people on the committee. And more than half of them are DOD, but there's a substantial number of commercial people there. And we've never had one standard that applies to defense as well as commercial, domestic as well as international. It's always there's a number of standards. So we're attempting to have one standard on FMEA, and we're bringing together people who've had their entire careers in one silo of application. And it's the most interesting, and I'll say lively conversations, contentious sometimes, to get people to see the other side of things, and it's working. But it's a lot of labor.
Yeah, no, I've been at some of those committees, and they spend an amazing amount of time working on one sentence. The first one I went to just to check it out, see if I wanted to be a part of it, I almost walked away with my head shaking. Is they spent the entire hour on one sentence, and it wasn't even an important sentence.
Oh, God.
In wordsmithing and rewriting it. And so they had it all exploded into a paragraph, and then it came all the way back to pretty much exactly the same sentence. It was, instead of the participle being here, it was moved over there or something like that. It was,
oh
my gosh.
That's painful.
It is. But I imagine if you can stay with the principles of, especially around detection, and one of the quotes you use all the time, it was, keep the end in mind. What is it we're actually trying to do? We're not trying to fill out a form or meet a legal requirement because our customer requires it. We're actually trying to create a better product.
Yes.
And so if we dither over whether it's sensing or detection here or there, or the other thing, we're kind of losing sight of the big game here and what we should be doing.
Exactly. In fact, that's a good way to round off this conversation is the subject of detection or not, or when it is and everything. I agree completely. We have to keep in mind the principle. If we're doing an FMEA, on design FMEA, to improve the design, make sure it's safe and that it works. We're doing a process FMEA to improve the manufacturing process. Those are the things to keep in mind. And if identifying detection risk helps you do that, and that's great. But if you get bogged down into some detail that is not value added, then move on.
Yep. And that applies to a lot of the FMEA stuff. It's
yes. Yeah. Yes, it does. It applies to a lot of things outside of FMEA.
Yeah. But no, it's a good way to sum it up.
I want to encourage people, because this, like I say, this is one of the more confusing areas. When I teach FMEA, it is often a discussion that takes some time to get the principles clear in people's minds. And so if you're a listener and you have any stories or questions or concerns about detection in FMEA or anything that we've talked about, we would love to hear from you.
And you can do that over at accendoreliability.com/go/SOR. A couple of ways to get in touch with us there. Carl and I and the other hosts of the show are available through LinkedIn and our About pages. And while we were talking, I got a couple of blurb. I hope it doesn't show up in the recording. It's a signal that I got a text message.
I didn't hear it.
No, you didn't hear it. Okay, so it's probably just on my system. but now I need to turn off that detection system because it's annoying.
Yes, there's a lot of things about detection that can be annoying if they're not value added.
That's right. All right, good one. And so hopefully you answered back to the person that asked, and we've added a little more thought to it here. So I hope it helps answer the question that is bound to be in other people's minds. So we
Very
always
good.
look forward to it. All right, good, Carl. Good talking to you. We'll talk to you again soon.
Talk to you later.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.